I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will discuss about the local search algorithm used in AI. Local search algorithms in AI are optimization techniques used to find solutions by iteratively improving a candidate solution based on a defined criterion. They are particularly useful for problems where an exhaustive search is impractical due to large search spaces. Unlike global search methods, local search focuses on exploring neighboring solutions to find an optimal or near optimal solution. Common examples include guilt claiming, simulated annealing, genetic algorithms, taboo search, partial swarm optimization, etc. These algorithms are widely applied in areas like scheduling, robotics, and game playing. We'll see one by one. First, we'll see what is local search algorithm in AI. Local search algorithms are heuristic based methods designed for optimization and constrained satisfaction problem. CSP. CSP represents constrained satisfaction problems. CSPs where the objective is to find optimal or near optimal solutions by exploring neighboring states. This is what we are doing it in this case. Unlike global search algorithms, what are all the global search? Informed and uninformed searches, namely A star or breadth first search, etc. Local search does not maintain an entire search tree. It will not be searching the entire search tree. Instead, it focuses on iteratively improving a single solution by making small modifications and evaluating their impact. These algorithms are particularly useful for large problem spaces where exhaustive search is impractical. Examples of local search techniques include guilt clipping, simulated annealing, genetic algorithms, taboo search, local beam search, etc., each of which applies different strategies to avoid local optima. This we have to verify. To avoid local optima. So we have to avoid this local optima in this to and improve the search processes. Next, what are all the key characteristics of local search algorithms? First, use a single current state rather than multiple paths. In this case, local search algorithms focus on a single current state instead of maintaining multiple paths or exploring an entire search tree. This approach makes them memory efficient. Instead of going for multi-path, it will be using only one state, that is current state. So what is the advantage of using to go for the single status? It will be safeguarding the memory. So this approach makes them memory efficient. So we can say that this is the memory efficient and well suited for problems with large state spaces. Unlike global search methods that keeps track of all possible paths. So in global search, that algorithm will search all the possible paths. Local search modifies and improves a single candidate solution iteratively, reducing the computational complexity and also storage requirements. Next, moves to neighboring state to improve the solution. How? Local search operates by evaluating neighboring states of the current solution and moving to a better one if it exists. This iterative improvement process helps refine the solution over time. For example, in the guilt clumping algorithm, the algorithm continuously selects the neighbor with the highest value until no better neighbor is found. This mechanism ensures steadily progress toward an optimal or near optimal solution, making local search suitable for real time and high dimensional optimization problems. And the third characteristic is does not guarantee an optimal solution, but it is an efficient for large problems. How it is possible? A key limitation of local search is that it does not always guarantee finding the globally optimal solution. It may get trapped in local optima, and where no better neighboring state exists, even though a better solution is available elsewhere in the search space. However, its efficiency in handling large scale problems make it a valuable approach in practical scenarios where an exact solution is not necessary, but a good enough solution is acceptable within a reasonable time frame. Methods like simulated annealing and taboo search help mitigate this limitation by introducing randomness or memory based strategies to escape local optima. And the fourth characteristic is it is useful for continuous and discrete optimization problem. Local search is widely used in both continuous and discrete optimization problems. In continuous optimization, it helps find optimal values for mathematical functions such as in neural network training or engineering design, etc. In discrete optimization, it is applied to combinatorial problems like TSP. We can call it as traveling salesman problem, TSP, job scheduling, and 8-Kun problems, etc. Its flexibility across different problem types and its ability to handle complex search spaces make it a powerful tool in various fields, including AI, artificial intelligence, operation research, that is OR, and OR, operation research and machine learning, ML. Next, we will see what are all the types of local search algorithm. There are four types of local search algorithm: gil glimping, simulated annealing, genetic algorithm, we are calling it as GA, and local beam search. Local beam search. These are all the types. Just we'll see the introduction about these types. The gil clumping algorithm, we'll see the detailed explanation for this slide. Gil clumping is an optimization algorithm that starts with an arbitrary solution. It will start an arbitrary solution and makes iterative improvement to find a better solution. The process begins with an initial state, and the algorithm continuously evaluates neighboring states to determine if they offer an improved solution or not. If a better neighbor exists, in this case, the algorithm moves to that state and repeats the process until no further improvement is possible. This approach is commonly used for solving mathematical and artificial intelligence problems, particularly in search and optimization. The algorithm stops when no neighboring state offers a better solution, which means it has reached a local maximum or minimum. Additionally, it may terminate after a fixed number of iterations or if the improvement in the objective function is insignificant. These stopping conditions help control the computational cost while ensuring a reasonable solution is found. There are several variants of hill climbing algorithms that modify how neighbors are selected. The various approaches or variants are steep ascent hill glimping. It chooses the best neighbor and it evaluates all possible neighbors and chooses the best one, making it computationally expensive but effective in finding optimal solutions. Next, first choice, gill clumping selects the first improving neighbor it encounters, leading to faster but potentially less optimal solutions. Stochastic guild clumping introduces randomness by selecting neighbors randomly and moving to a better state if found, helping the algorithm escape local optima. This we should know. What is local optima? We'll see it in the problem. An example problem. Our local, it may be stucking at this. Despite its efficiency, guild clumping has several limitations. So, what are all the limitations you should know? One of the main drawbacks is that it can stuck at local maxima, here it is there, where no immediate neighbor provides a better solution, even though a better solution exists elsewhere in the search space. Another issue is encountering plates where multiple neighboring states have the same value, leading to the stagnation. Additionally, ridges. This we'll see it in the problem. The ridges, which are narrow pathways of improvement, can make it difficult for the algorithm to process effectively. These limitations can sometimes be mitigated by using variations of the algorithm or hybrid approaches such as simulated annealing or genetic algorithms. Guild clumping is widely used in artificial intelligence, robotics, game playing, and scheduling problems. It is particularly useful when an efficient heuristic is available and when the search space is too large for exhaustive exploration. While it does not always guarantee and in finding the optimal solution, its simplicity and efficiency make it a valuable technique for many real world applications. Next, the introduction about the simulated annealing. In the simulated annealing is an optimization algorithm. It has been inspired by metal, that is cooling process of metals, where a metal is heated and then slowly cooled to reach the stable, low energy state. This technique allows the algorithm to make occasional bad moves, that is, moves that do not immediately improve the solution. This unique property helps the algorithm escape local maxima. Local, it helps us to escaping from the local maxima. How it escaping the local maxima? Here we are using this unique property helps in local maxima and explores the search spaces more effectively, increasing the chances of finding the global optimal rather than getting stuck in the suboptimal solution. The algorithm operates by using the temperature parameter. This is the main parameter which starts high and gradually decreases over time. At higher temperature, the algorithm is more likely to accept worse solution to encourage explorations. As the temperature lowers, what will happen here is the acceptance of the bad moves decreases, allowing the algorithm to focus on refining the best solution found so far. This cooling schedule helps balance exploration and exploitation, preventing premature convergence to poor solutions while ensuring steady progress toward an optimal outcome. Next, one of the key advantages of using the simulated annealing is that it reduces the risk of getting stuck at local maxima. Traditional guild clumping algorithm often suffer from which problem? Suffer from this problem because they only move toward the better solution. However, by occasionally accepting worse moves, simulated annealing provides a mechanism to escape such traps and continue searching for better solutions elsewhere in the space. And the simulated annealing is widely used in optimization problems, including combinatorial problems like, as I've said previously, TSP, traveling salesman, job scheduling, and circuit design. It is specifically useful in cases where the search space is complex and traditional local search methods struggle with the local optima. While the success of simulated annealing depends on choosing an appropriate cooling schedule and temperature functions, Its flexibility and ability to avoid premature convergence make it a powerful tool in artificial intelligence and operational research (OR). Next, we'll see the introduction about the genetic algorithm GA. We'll see the detailed explanation for this GA, genetic algorithm. Genetic algorithms, we are calling it as GAs, or optimization techniques inspired by the principles of natural selection and evaluation. Unlike traditional local search methods, which works with a single solution at a time, GAs operate on a population of solutions. These solutions evolved over multiple generations through a process that mimics biological evolution, gradually improving the quality of solution to an optimization problem. The algorithms begin with how it will be begin. This algorithm begins with an initial population of randomly generated solutions. Each solution, often represented as a chromosome, is evaluated based on a fitness function which determines how good the solution is. The algorithm then applies three key genetic operations. This is very important, objective type questions. Three important operations are selection, crossover, and mutation. Selection, crossover, and mutation. Selection chooses the fittest solutions to pass their traits to the next generation. Next, crossover. The crossover here, it means a recombination. Recombination combines features from two parent solutions to create new offspring, introducing diversity. Next operation is the mutation. What do you mean by mutation over here? Mutation randomly alters some solutions to the solutions to maintain genetic variability and prevent premature convergence to local optima. One of the main advantage, coming into the advantages, if you are going for here, three types of operations are selection, crossover, and mutation. That I have told you. What do you mean by selection? What do you mean by that is crossover and mutation? One of the main advantage of genetic algorithm is that their ability to effectively handle large and complex optimization problem. Large and complex optimization problem. Since GAs explore multiple solutions simultaneously, they are less likely to get trapped in local optima, making them suitable for nonlinear, high dimensional, and combinatorial problems. They have been successfully applied in these algorithms: machine learning, scheduling, scheduling, robotics, and game playing. These algorithms are used in game playing and engineering design. Engineering, ED means engineering design. However, their performance depends on factors like population size, mutation rate, selection strategy, which must be carefully tuned for optimal results. Next type is the local beam search. This beam search explanation will see it. Beam search is an optimization and search algorithm that maintains a fixed number of best candidate at each step instead of working with a single solution like gil clumping, etc. At every iteration, it evaluates multiple possible solutions and retains only the most promising ones, effectively narrowing the search spaces while ensuring the diverse potential solutions are explored. This approach makes it more systematic and robust compared to purely greedy methods, what we have seen in the informed and uninformed searches. Unlike gill clumping, which follows a single path and may get stuck at local local optima, beam searchers simultaneously consider multiple paths. This parallel exploration increases the likelihood of finding an optimal and near optimal solutions, especially in complex search spaces. The algorithm continues iterating until a satisfactory solution is found and a termination condition is met, such as reaching predefined number of iterations or not finding further improvements. And the key advantages of this local beam searches are is that it is more robust in finding better solutions than traditional local search methods. By maintaining multiple candidates at each step, it reduces the risk of getting stuck in suboptimal solutions and improves overall efficiency. This beam search is widely used in NLP mainly. NLP means natural language processing, speech recognition, machine translation, and game AI, where multiple promising solutions needed to be evaluated simultaneously to achieve the best possible outcome. Next, advantages and limitations of this gill clumping algorithm. Gill clumping is a simple and easy to implement optimization algorithm, make it, making it a popular choice for solving various searches and optimization problems. It is highly efficient for small scale problems where the search space is not so complex. One of its biggest advantages is that it does not require maintaining an entire search tree or graph, as it only keeps track of the current state, reducing memory usage and computational overhead. However, even though it has got many advantages, however, gill clumping also has several limitations. One major drawback is that it can stuck at local maxima. It's stuck at local maxima where a better solution exists, but the algorithm cannot reach it due to its greedy nature. Additionally, it struggles with the plates, flat region, ridges, steep or narrow paths, where small changes in the state do not provide meaningful improvement, leading to stagnation. This I have already told you. Lastly, gill clumping does not guarantee finding the global optimal as it focuses only on immediate improvements, which may prevent it from exploring better solutions elsewhere in local search. So this is the advantages of gill glimping. Don't confuse the other types of types advantages and limitations. We'll see it later. Next, application generally. This is the applications of local search. The local search algorithms are widely used in optimization and artificial intelligence due to their efficiency in solving complex problems where the optimal or near optimal solution need to be found. And these are all some of the applications of this local search algorithm. First one is scheduling problems. What do you mean by scheduling problem? Job scheduling, airline scheduling, etc. Local search helps optimize scheduling tasks by efficiently allocating resources and minimizing conflicts. So this will avoid the conflicts. In job scheduling, second, and in this case, in job scheduling, airline that is, it avoids the conflicts. In job scheduling, what will happen here? It determines the best order of task execution to maximize efficiency. In airline scheduling, it optimizes the flight assignments, crew scheduling, and maintenance planning to reduce costs and improve efficiency. The next application is the traveling salesman problem, TSP. The TSP require finding the shortest possible route for an salesman visiting multiple cities exactly once before running to the starting point. Local search algorithms like gill clumping, simulated annealing, and genetic algorithms are commonly used to find near optimal solutions efficiently. Next, robot path planning. How it is being used? Robots require efficient navigation to reach their target while avoiding obstacles. Local search helps optimize path by minimizing travel time and avoid collisions. Algorithms like A-star search and simulated annealing are commonly used in robotic applications. The next application is the applications of local search is neural networks. Training in this neural network training in Let's say, for example, in machine learning, local search techniques assist in optimizing neural network parameters such as what are all the parameters, weights, biases, and improve accuracy. Gradient descent local search based optimization method is widely used in deep learning models. So the next application is the game AI. Example, Chess Go. Local search is crucial in game AI where algorithm like minimax with in this case minimax with alpha beta pruning and Monte Carlo tree search helps AI make strategic decisions. It enables AI to evaluate multiple move sequences and select the most promising one to maximize its chance of winning. Local search techniques are powerful tools in real-world applications, offering efficient solutions in a domain where exhaustive search methods are computationally impractical. Hope you have enjoyed about the introduction about local search algorithms. In the forthcoming lectures, we'll see the example problem for all the four types. What are all the four types? Gill clipping, simulator annealing, and genetic algorithms. Hope everyone enjoyed this lecture. The remaining things we'll discuss in the next lecture. Thank you.